good. Welcome back to my YT channel. Let's go back to business once again. This is your YouTube content creator and this is your channel voice. Okay, so I need to introduce to you two more problems, physics problems in regards to the gravitational force. Okay, so I will use the red pen. Yeah, di ba? Okay. So the first problem will be dealing with, derivation of equation. Okay? And the second one will be, it's a little bit of direct substitution, right? Okay? Like this. Oh, it's not clear. You see me now? Okay. I adjust. Okay, so that you can see the whole screen. Oh, right? Wait. Like that. Oh, perfect. Match. In short, match with the color of the whiteboard, right? Okay. So, oh my gosh, I have so many problems. I have 53 problem solving questions in physics. Okay? So it's gonna be like we'll choose the we will choose the most easy, average, a little bit average, or sometimes also a little bit difficult, right? Okay, this one. So many guys. Okay, this one. Calculate the gravitational field strength. Oh my gosh. Okay. Calculate. Can you see my penmanship? Calculate the gravitational field strength. Gravitational. I discussed to you last, one day ago, right? Gravitational field strength. The theory behind this. Okay. Like this. Okay, by the Earth. Oh my gosh. Talaga, planet Earth. By the Earth. Oh my God. Okay, A. At the Earth's surface. Secondly will be this 5,000 kilometer above the Earth's surface. Oh my gosh, 5,000 kilometer above the Earth's surface. Okay. It looks like this is a planetary science, right? Okay, above the Earth's surface. Okay, like this. Okay, ganon. Yeah, right? Looks like easy, right? So calculate the gravitational field strength by the Earth. So let's have an acronym for this so that for easy memorization. We have GFS. So it also calculate the GFS, meaning the gravitational field strength. Okay, now we need to equate the GFS to EDG. So Sotero, what is ADG? So these are all acronyms, right? GFS, gravitational field strength. ADG is acceleration due to gravity. Okay, so the value of ADG or acceleration due to gravity is 9.81 meter per second squared. SI unit per metric system. And in English unit will be 32.2 feet per second squared English unit. And then it would have the same value for your GFS also. Okay, this is gravitational field strength. So instead of putting meter per second squared, you have to put 9.81 Newton per kilogram. SI or metric system. And then for English unit, it's gonna be 32.2 Newton per kilogram. Oh my gosh, really? Okay, something like that. But you need to convert also this one to make it sure. But I am sure really for the Newton per kilogram is 10.81. As long as you have the same value right here. Okay? So because your English usually involves feet right here, somewhere here. So feet like that. So if that's gonna be feet and then you will be having kilogram convert into pound. Okay, so we need to recall our conversion factors in terms of pound, kilogram, gram to pound. For example, I have here 1 pound is equal to 454 grams, right? And then it's gonna be, correct me if I'm wrong, because this is very long time ago during my grade school level or high school level. So it's gonna be like 1 kilogram is equals to 2.2 pound. Correct me if I'm wrong. Okay? So these are the basic conversion factors that we need to memorize. Okay? So 1 pound is equals to 454 grams. 1 kilogram is equals to 2.2 pounds. Am I correct? Okay, I'm not really sure in the second, but this one is sure. 1 pound is equals to 454 grams. Since I have a doubt, then I have to prove this 1 kilogram is equals to 2.2 pounds. Maybe it will be reversed. Maybe 1 pound is equals to 2.2 kilogram. But I think so. It's gonna be 1 kilogram because kilogram is higher than a pound. So the more it is higher, the more your numerical figure will be lesser. That's what I understand in math regarding conversion factors. Okay, something like that. Ikatapot mga palangga. For example, I have 1 feet. Okay, so based on our stock knowledge, that 1 feet is equals to 0.3048 meters. See, the meter will be point, and then the feet is 1, meaning feet is higher than a meter. Okay, so that's why it's less than 1, the meter. The same here also. We know that the kilogram is higher than the pound, so we need to say you have a higher value of your pound, 2.2, something like that. Okay, you get the point. So let's check this out. It's needed in our problem here. Okay. Okay, I don't want to be bookish. Okay, so it's gonna be like that. So, okay. Now we have also 1 meter is equals to 3.28 feet. Right? So it's gonna be like that. So the reverse for that is gonna be like this. Meter to feet, feet to meter like that. But if you don't want to memorize, just convert that. Starting from centimeter to 100 meter to millimeter until such time you will be going there to feet, meter, meter, feet, because we still have 100 centimeter is equals to 1 meter na ganon. 1,000 meters is 1 kilometer. Okay, ganon. So, di ba? So, mag-centimeter po ta. 1 inch is equals to 2.54 centimeter. Then 12 inches is equals to 1 feet. Then you can arrive here. 1 feet is to meter, meter is to feet. So that will take longer. That's why when I was in my high school, in the second year or first or something like, I memorized this already. This all conversion factors. So that when I go to college, it will now become a review on my memory retention regarding conversion factors. And that's what I'm using until now in front of you. Okay, so let's review the 1 kilogram, 2.2 pound, if it is really correct. I need to prove because in the benefit of the doubt. Okay, so we start from 1 pound is equals to 454 grams. So let's say 454 grams. Okay, 1,000 grams is equals to 1 kilogram, right? Something like that. Okay, na natin kilogram o ganon. So you should know the kilogram to pound. Ganon. So since this is already a pound, see 1 pound. Okay. So how much? So 4 divided by 1,000. So that is kilogram na siya. Or you will see also, para di ka maglibog, mo start ka sa pound. So 1 pound. Okay. And then 454 grams. Atong i-divide siya to solve because so that we can easily get the answer. Okay? So 454 divided by 1,000. 1,000 divided by 454. So, di ba, 2.2. So, okay, this is gonna be 2.2, and the reverse will be 1 over 2.2. And this is kilogram. And this is pound. Right? Ganon ganon. So, let's do ratio and proportion so that we can easily get, if we have the if we have the pound as X and we have the grams in terms of kilogram, which is 0.454 kilogram. So this is basically basic math. You don't have to complicate this. Okay, 0.454 kilogram. And then if we have 1 kilogram here and we have 2.2 pound here, something like that. Okay, you get the point. Or your X will be 1, so that you can determine what pound is your 1 kilogram. Right? It's gonna be like this. I will say 1 over 0.454 kilogram. So be consistent in your unit. You put in the numerator, which is a pound, and you put kilogram in the denominator, right? So your ratio also will be on the second, on the right, will be also pound in the numerator. So your pound in numerator, in which you are not really sure, you put that as X because you don't know. I need to prove if my memorization is correct. That I say 1 kilogram is equals to 2.2 pound. Maybe the reverse will be happening. That's why very long time ago. So maybe I will be wrong, right? So X is equal to the kilogram here, which is 1 kilogram. Okay, mga palangga akong hitad. Okay, so how can you do that? So cross multiply mga palangga. So 0.454, ganon, X is equals to 1. O diba? So i-divide mo ang 1 divided by 0.454. So 1 divided by 0.454 is equals to 2.2. Okay, 2.2, and this is pound, right? I'm correct. Perfect. 1 kilogram is equals to 2.2 pounds. So my memorization did not fail for 23 years ago in my college of in my education from elementary, high school to college. See how many years? Still correct. And I have to prove because it was very long time ago. Okay? Something like that. So, any questions so far for the conversion factors? And you have to master this if you're going to take up a Bachelor of Science in Engineering courses. Because our foundation will be math conversion factors. Okay? In solving general engineering related questions. Okay? Ganun. Expected na siya yung mga palangga. Ha? Okay. So now you need to solve now. We go back to the problem. We need to do this because we need to solve in that approach. Maybe there's a conversion factor somewhere along the way. Right? Ganon. Okay, so what's the first step for this? We need to illustrate or we need to draw. Okay, or to have a, shall we say, a schematic diagram or a symbol, a flow chart, a black flow diagram, something like that. So anything that we need to illustrate, okay? So gravitational field strength, Earth. Okay, so we have the Earth here. Okay, Earth. This is the planet Earth, and June, myself, is standing here. Actually, all of us are standing in the outer layer. We are not standing inside the circle. That's why we have gravity, because if we don't have gravity, then we will be thrown away into the universe. See? Like this. Natuwad ta diri na, tungtong ta diri o. So, meaning to say, we will never be thrown away to the universe or to the outer space because we have gravity. So we are not here in the center, ha? Remember, we are outside from the center. And the land is also here. Land and the water here, like that. Okay? And the body of water is until the center. Okay, and earth crust, meaning layer to layer, like this: first layer, second layer, third layer, until such time the water will come out. Okay, because it's in the deeper portion of the land in which we can explore the body surface of the water. Okay, which is 75% of the earth, or 3/4 of the earth surface will be the water. Okay, so there are more water than the land in our planet Earth. So if you try to put that in an analogy of a person also, there are more water of a person compared to the food we eat. So we have also 75% and 3/4 fraction of water we drink. The water we mean here is a fluid. Could either be the plain water, the juices, okay, the alcoholic content, or any drinks that we drink. So we are more on liquid. Okay? Tantamount to the earth also. The same analogy. Okay? You get the point. So we need to discuss that so that we can answer properly. So what is the gravitational field strength? The GFS. Like that. Okay? Ganon. So how can we solve this at the Earth's surface? Now, we have force is equals to the mass times the acceleration to the gravity. This one. This is the familiar equation for the force of gravity. Okay? This will be applicable, guys, if there are no two masses involved in the problem. Okay? So, actually, this is the other version, which is the more simple version. Okay? Like this. So, if you try to look to the problem, there's no other objects involved. Okay, so I have to use this. The force is equal to the mass times the acceleration due to gravity. Or we'll say, force is equals to the mass times the gravitational field strength G. As I told you, the G, the small letter G, goat, okay? Not zebra. Okay, the G, small letter G, is also the gravitational field strength and also the acceleration due to gravity, but differ in the unit of measurement. Okay, something like that. So we need to compute. So by math, okay, this will become divide both sides by m, so that we can have the gravity or gravitational field strength. Cancel. So it will become G is equals to force of gravity F divided by the mass. So this is your equation 1. Okay, so if you love really to solve mathematics problem, then you will be enjoying if you found so many equations. Equation 1, equation 2, equation 3, equation 4, equation 5, equation 6, equation 7, and finally your simplified equation or your derived equation out from your plenty of equations that you elaborated somewhere along the way. Okay, now this is equation 1. Ganon. So, ganon. Okay, so we need to solve the gravitational field strength. Okay, now in our problem mga palangga, komunidad, there's no force yet. Okay, X, Equals. And there's no also gravitational field strength, Equals. So there are two unknowns, okay? But three unknowns talaga actually based on the problem. But since we have the memorization technique of the standards of the Earth, we need to memorize this also as early as possible because it will be also coming out every time in our higher science, especially physics. But not so much with the major, okay, but only physics, okay, like that. So we will memorize that as early as now, that the mass of the Earth is gonna be 5.97 times 10 to the 24. So how heavy is the Earth really is? Okay, 5.97 to the exponential 24. Oh my gosh, how much is that? Cannot be measured by trillion, quadrillion, what is pentallion, heptallion, or whatever. Okay, so what is raised to the power 24? As far as we can remember with our prefixes in math, again, going back to the prefixes in math, right? So let's say, wait mga palangga, because I need to recall the stat knowledge. Let's say, if you try to start with 10 to the 6, this is mega. Okay? That's why we have megabyte, 10 to the 6 byte. Okay, the unit of measure in the storage of the computer is BYTE, byte. That's why megabyte, 10 to the 6 byte. Now, next, 10 to the 9. This is giga. So gigabyte. That's why we have also storage in the computer, which is gigabyte, meaning 10 to the 9. 10 raised to the power 9. So what's next? Okay, after giga, nakakaloka. Okay, what is 10 to the 12? What's this? Okay, this is tera. Tera is higher than gigabyte. Terabyte. If you buy in the market, which is a terabyte, it is more expensive than a gigabyte because the storage is higher than the gigabyte. So it's gonna be 10 to the 12 tera. Okay, what's next? We have also peta or petabyte. So that's gonna be 10 to the 15. Okay, petabyte. What's next? 10 to the 18. Oh my God, nakakaloka. So it's gonna be exa. Okay, ganon. Okay, so this is exabyte. Okay, until 10 to the 20, 21, 10 to the 24, 10 to the, until infinity. But we have now 10 to the 24 is the mass of the earth. So we cannot equate to the prefixes in math is beyond. Because 10 to the 24, until ano tayo 10 to the 18 exa. Okay? Okay guys, in the exa, guys, that is huge also. That's why in the exosphere, nobody will exist in the exosphere. Because all metals will be melted there in the region of the exosphere. Diba? We have atmosphere, lithosphere, hemisphere, stratosphere, hydrosphere, right? If you can remember that one. Then we have also the exosphere. When you reach that region, all will be burned at a higher temperature. The earth, the airplane will never reach there. Okay? The jet will never reach there. Only the equipment of the NASA can go beyond there. What do you call this one? The satellite, something like that, will go beyond there. Okay, and then so the speed is so very high, because if the speed is not very high, then it will be melted also. It will go beyond like that only. So the higher temperature will not be affected. It will not be affected because the velocity is very high. So how can we prove that? If we have a candle, we will buy a candle in the bakala or in the market, then burn that with a match and try to touch your finger very fast. You will not be burned. Why? Because you have a higher velocity. So that philosophy, that analogy is the same as the satellite in which our astronaut is riding. Okay, they will be turning back 1,000 years after, they will come back to the earth for their experimentation, what's there. So it's gonna be basically that idea. So of course, it will never be burned because that's having a fast velocity. Okay, you get the point? In the exosphere, if you stay there, okay, you will be burned and you will be melted with a very high temperature. Okay, we are only existed in the stratosphere, the airplane, like that, the jet plane. But beyond that, in the exosphere, like about the last region, too much hot. Okay, ganon. Okay, why? Explain ako sa physics. Because very hot existed at a higher elevation. Okay, the hot water usually in the higher elevation than the cold. Okay, meaning to say that the cold has a lower elevation compared to the very hot air, higher elevation. So like that, and then you will see also which is more heavier, the hot air or the cold air? heavier. Of course, the cold air, because it stays on the bottom. The more it stays on the bottom, meaning it is heavier. Okay, because the gravity is directed downward. You get the point? So that's gonna be like that. There's also a question like that in the theory. Which is more heavier, a hot air and a cold air? Nani mabuang kang kinumpute, you will be fool to compute because it's not really mathematical, it's theory. You get the point? And you will say, the density, you will compute everything, the density, the ganon. So it's not like that. You will go to the theory for that. Okay. The cold air will be more on the lower part, and the hot air will be on the upper part. That's why the more it will go into the upper part until you reach the exosphere, which is very hot, and nobody will survive there in that region. Okay, it's gonna be like that. So another reason also, cold air contains more of a moisture through the understanding of the relative humidity. Okay, you got the point of relative humidity. You need also to measure that by means of a psychrometer, a device used to measure the humidity, the relative humidity content, something like that. In terms of moisture, per meaning PER over the total mixture of air. Okay? Ganun. So that's why during humid, it will remove all our moisture from our body. Something like that. And the more we will become sweat because of relative humidity. Okay? Because it is the moisture there in the numerator. Okay? Percentage of moisture over the percentage of the total air mixture. Okay? You get the point? Ganon. So that's why cold air is heavier than a hot air. Okay? Because of the presence of the moisture. Just like also when you wash our clothes. If it is still wet, it is more heavier than the dry one. Okay? Because there's moisture, common sense. Okay? The weight of the water was the weight of the clothes. But if it is dry, there's no weight of the water. Of course, it is lesser. It's not heavier. Things like that we can answer by common sense, right? Not really necessarily by the book. Okay. Get the point? Ganon. So going back to this topic, ganon siya. Nasa equivalent sa mga negative ha, kung mas TBC, mga ganon. Okay? Pico, ganon. Okay? So we have ato, ganon. You get the point, mga palangga akong hitad, ganon siya. Femto, ato, ganon. Okay? So ganon siya. Okay? Nano. Okay, 10 to the negative 9, nano. O, diba? Okay. So, ganun. So, basically, it's also possible that you have a storage negative. Say, nanobyte. Meaning to say, 10 to the negative 9 byte. Because BYTE is the unit of measure of storage in the computer. Okay, or data. Okay, something like that. So, it's gonna be like this. So, we need to compute for it. We have to need more equations. The G and the F. Things like this, guys, is not direct substitution. If you encounter like this. So, we need to understand the derivation of an equation. Okay? So, in here, we don't rely on memorization. If we encounter things like this, because we need to rely on analysis on the problem. Because it's not direct substitution. You get the point? So it's gonna be like that. So we have equation 1. So what is that equation of force? Okay, we need to have the equation of force. What is this? See, gravitational field by the Earth. Remember, guys, if the Earth is always revolving in the center of the Sun is the center of the universe, according to Galileo Galilei. He is the scientist that says that the Sun is the center of the universe, and after that, the other one is aristocrat. No, it's not aristocrat. After that, we have Nicholas Copernicus. Mr. Nicholas Copernicus corrected the theory of Galileo Galilei, and then the credit is given to Copernicus. Okay, the Sun is the center of the universe. Okay, this is discussed in our elementary level, grade school level, grade 2, grade 1, grade 3, grade 4, like that. Okay? So scientists in a planetary science, right? Okay. What? Ganon. So, monishin metabo. So, we have the force of gravity. The F here will be now the force of gravity because this is gravitational field strength. Okay? Ganon. Oh. So, force of gravity, Fg. Oh, ganon. So, how can you attack this kind of problem? Attack na yun, attacking. Okay? So, it's gonna be, since this is the Earth, then it will rotate to a certain orbit, which is circular path. Okay? So, it's gonna be using the centripetal force concept, meaning the force is directed to the center or the centroid of the universe, which is the sun, right? So, it's gonna be like mass times the velocity squared over the radius. Okay? You get the point, mga palangga pangitan. Then substitute this value in here so that we can get an equation 2. Okay. Gravitational field strength is equals to mass times velocity squared over the radius capital R. Okay? Diba ganon? And then over the mass pa siya. Okay. So, get the common variable, cancels the mass. So what is left is gravitational field strength is equals to velocity squared over the radius. Okay. This is your equation 2. Okay. Now, can you answer now with your equation 2? By looking at the problem, what is the gravitational field strength? You don't have the velocity. Right? So you can still solve. So you need still another equation. Okay? That involves velocity. Okay, your third attack is to do the gravitational force in terms of the law of Isaac Newton in the universe. Right? After Johannes Kepler have the 3 laws of planetary motion in the universe, and then Newton also has its own law. Because there are 3 scientists that focuses on space and time. We have first the Albert Einstein theory of relativity. We have also the Isaac Newton, which is the gravitational force. And then the third one will be the Johannes Kepler. These 3. But the original really is the law of Johannes Kepler. The Newton is only the development theory or laws from Johannes Kepler. So that's why we can obtain another formula, which is equal to, you should memorize this. F, gravitational force, is equals to the gravitational force constant times the mass 1 times the mass 2 over the radius squared. Okay, this attack or this equation, you will use that here also. Okay, like this here. Okay, so how can you do that? Okay, before doing that, this gravitational force, you will try to in equilibrium to the centripetal force also. Okay? So which is mv squared over r. To cut the story short, because it's, guys, I really hate this because my magnetic whiteboard is very small. I cannot expand my explanation very well. But forgive me, okay? Just take down on a blank sheet of paper as I talk. Okay, just listen to my discussion, something like that. Then you have to equate the gravitational force to the centripetal force, and to cut the story short, we can obtain velocity squared is equals to the G. G is the gravitational force constant, the Newton's law constant, or the universal gravitational constant. Okay, times the m over the radius. So this is our equation 3 that involves velocity. Okay, this is velocity here. Okay, now, since we don't need the velocity, okay, what will happen? We need to compute the velocity in terms of the gravitational field strength and the radius. Why? Because we don't need the velocity. So we need to treat that as a constant somewhere along the way. So derivation of an equation is always like this. You need to put a certain variable to be a constant so that it will become a simplified equation after all. Okay, something like that. But be sure that your constant will have also a match for your assumption, scientific assumption with your analysis of the problem. Because here we don't need the velocity. Okay, see? We don't need the velocity in the problem. If the velocity will be given, then bingo, I can solve directly the gravitational force, right? I don't go that far. But since there's no velocity, then I still have to derive another equations before, so that I can compute really the gravitational field strength in terms of the radius. Okay, ganan. Mga nasabihin mo, so tiruan mo na yung radius. As I told you, the radius and the mass of the Earth are standards, and you have to memorize that. And what is the radius of the Earth? Okay, like the radius of the Earth is 6.38 times 10 to the 6th meter. Okay, mo siya. 6.38 times 10 to the 6th meter. Oh, you can convert that to kilometer, you can convert that to miles, you can convert to the feet. Again, the convention factor will be this. 1 mile is equal to 5,280 feet. Okay. And then you can see also that 1 mile is equal to 3.08 kilometer. Okay, ganon. So, you can compute now meters to kilometer also. Very easy. Meter to kilometer is very easy. 1,000 meters is equal to 1 kilometer. Okay? But this is the little bit difficult part. 1 mile is equal to 5,280 feet, and 1 mile is equal to 3.08 kilogram. Okay, ganon. Ako yung mga palangga. Then, if you have also benefit on the doubt, maybe your memory fails, as what I did a while ago, then convert that in actual. Okay? To prove you are really wrong. Okay? Or you are correct or not. Something like that. So, naman tayo radius. So, daog na yun. We can compute for the gravitational strength. Now, compute for the V squared. Because we have also V squared common here. So, treat equation 2 and equation 3 is in equilibrium with each other because it follows the same principle and concept. So compute for the V squared from equation 2 is compute for the V squared. It's gonna be V squared is equal to the gravitational field strength times the radius. This is our equation 4. Okay. Now V squared is already an equation 3, right? So rewrite and put that here. V squared is equals to Gm. This is not general manager, but this is gravitational force constant times the mass of the Earth. Gm. Okay? Over R. Maybe you will say general manager. Okay, over R. Okay? So, now, commonalities or common V squared equate that one. So, equate equation 4 to equation 3. Meaning, try to equal that one by having an equal sign. Okay? Like that, so it's gonna be 4 equal to 3, or equation 4 is equal to equation 3. I must say, gravitational field strength times the radius is equal to the gravitational force constant in the mass of the Earth over the radius. Okay. This is now our equation number 4. Oh, number 5. Sorry mga palangga. Equation number 5. Okay, as you can notice, there are 2r. Can we cancel this one 2r? No, it's not, because that is not in the same position. You can only cancel, based on math, you can only cancel if they are in the same position. For example, in the left, it's in the numerator, and in the right, it's also in the numerator. In the right, it's in the denominator, and in the left, it's also in the denominator. So in the right, it is in the upper portion. In the left, it's also in the upper portion. Like that. The denominator is in the lower portion, and in the left also is in the lower portion, so that you can cancel out. In this case, you cannot cancel because it is in the upper portion, the left, and in the right side is in the lower. You cannot cancel the r. Okay? So you will do the crisscross multiplication technique of math, or either dividing both sides to something chuba-chu-chu, so that you can get the correct variable in which we need to troubleshoot or to extract the gravitational field strength, which is the small letter G. Okay. Me, okay, in my engineering education before, I'm fond of doing crisscross multiplication because, you know, I will never be wrong because it's very easy to, okay, put an X. the x here is the diagonal direction where to multiply. Okay, so if you love also to do the dividing both side by something chupa-chucho, then you can also use that one. Okay? Like that. Ikita po yung mga palangakang hitad. Ganon. So, crisscross multiplication, GR times R is gonna be gravitational field strength R squared. Because R times R is R raised to the power 2. Is equal to the capital G times the mass of the Earth. Now, gravitational field strength is equal to the gravitational force constant, the mass of the Earth over the radius of the Earth raised to the power 2. Finally, this is our equation to be used, which is our equation number 6. Imagine in this kind of problem, we reach at least 6 equations to get the formula of this gravitational field strength. Okay? Like that. Now, if you encounter a problem like this, it's advisable you need to memorize. So that you don't need to derive again and again and again. If you see a problem like this, you will picture out by your brain cells in this kind of problem. Okay, gravitational field strength, ganon. So, it's gonna be 2 only. So gravitational field strength is equals to the velocity squared over r, or this one. Gravitational field strength is equals to the mass of the Earth times the gravitational force constant over the radius of the Earth raised to the power 2. Take note, it's not always the Earth. Okay? You can have object, you can have also Junjun, myself, person, object, all materials inside the planet Earth. This R and M. Okay, not limited only to the heavenly bodies in the universe. So we are fond of doing that because it's easy to detect the mass of the Earth and the radius of the Earth. Because if we try to consider objects, then we need to do experimentally. What is the standard radius? Or I need to get a measure tape measure. For example, the refrigerator has a mass like this, and Junjun has a mass like this. Calculate of the force of the gravity between the refrigerator and Junjun today in actual. So how can I do that? I will get the measuring tape. I will get the radius, something like that, and I know my weight. And I know I don't know the mass of the refrigerator, but I can compute that using this equation. So I can compute technically the gravity of the refrigerator inside my room and the gravity of myself. Okay, by having the masses and the distance. Because I'm telling you that is not limited only to the heavenly bodies. We can apply also through objects. Sometimes also ball, football, soccer ball, cricket ball, like that. Okay, any kind of ball or any objects. So na lang distance covered. Okay. You get the point? Ganan-ganan. So, substitute ng takin, substitute sa matang pangitaas na. Okay? G is equals to, 6.67. Memorize siya guys. 6.67 times 10 to the negative 11. Okay, Newton meter squared kilogram squared times the mass of the Earth as I told you earlier, 5.97 times 10 to the 24 kilograms. Okay? Over the radius of the Earth, 6.38 times 10 to the 6 meter. Then cancels the unit, it will become Newton kilogram. Okay, because this is gravitational field strength. Okay, don't put meter per second squared because it's asking for the gravitational field strength. If it's asking for the acceleration due to gravity, can put that meter per second squared. Okay, but the same magnitude. So, what is magnitude? Magnitude is a numerical figure, a digit, a number. For example, I have 2 meter per second. My magnitude is 2. Okay, unit is meter per second. Okay, so since speed, that is scalar quantity, I don't have to mention the direction. For example, if I will say 45, the velocity is 45 meter per second. So that is already a vector quantity. Then you need to say your magnitude is 45, your unit is meter per second, and your direction will be specified. If it is in the north, in the east, in the west, in the south, in the back portion, in the front portion, in the left portion, in the right portion at a 360 degrees angle of inclination, 45 degrees angle of inclination like that. There must be a rotational location or a positioning or orientation of the location and position if we are trying to say that it is a vector quantity like a velocity, acceleration, like that. Okay? So we need to say when velocity and when speed is not technically the same. Okay, due to the issue of the direction. Okay, but technically the same with the magnitude only, which is the unit, meter per second. Okay, so we will not mix up this in a problem solving because that's very, very important. Okay, you get the point. For example, calculate the velocity of blah 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 so and so. That is not speed. Okay, because you will measure if it is going up, going down, left and right, and the signs will play an important role in math. If it is up, positive, negative, okay, decelerating, something like that, downward motion. Left also is negative, right is positive, so that would be the velocity. But the speed doesn't consider that signs effect or doesn't consider the direction. That's the difference between a velocity and a speed. Okay, klaro ta, nag-agree ta diha, okay? That's why we need to say the wind velocity. Southwest, okay? Southwest, east to west, north of east, like that. There's a direction, that is a velocity, not a speed, okay? You get the point? Something like that. Okay, so our answer will be, okay? This is raised to the power 2. Mga palangga kong hitan. Okay? Diba sa'yo na siya? Diba? Ana-ana lang. Okay? So, when you solve problems, treat that as a game. O parang laro-laro lamang. Parang gano'n. Okay? So that you will be happy in solving. Do not treat that as a burden in solving problem. Okay? Okay? So, just treat that as a game. Okay? Na parang laro-laro lamang. Ganon. So, ganon siya. Now, atong i-exponent mga palangga ha. Okay, really squared man siya mga palangga. Ano? So, 6.38 exponent to the 2, right? 6.38 exponent to the 6 exponent pa jud siya. 4.0713. 6. Huge exponent. This is the, you know guys, this is the disadvantage of this topic because it involves a huge exponent. Okay, be careful in using your scientific calculator. Okay, so 4.07. Okay, you cannot estimate, you cannot approximate because huge exponent. Okay, times raised to the power times 10 raised to the power 13. Ganon. Ang numerator will be, okay, GM. So G is 6.67 exponent to the negative 11 times the mass of the Earth, 5.27 exponent to the 24 is equals to 3.981. 3.981, okay, times 10 to the 14. Ganon. So pila atong gravitational field strength, okay, divided by 4.07044 exponential to the 13. Now our gravitational field strength is 9.78. Okay? 9.78 is so our gravitational field strength. Gravitational field strength is equals to 9.78. Okay? This is Newton per kilogram. Take note. We have a standard value of 9.81 Newton per kilogram. Kilogram is our standard gravitational field strength. So it's lesser than. It will never go beyond. So your barometer in checking that you are really correct in your answer, it will not go beyond 9.81, okay, Newton per kilogram because that's already a standard. It's not beyond. So it is a standard because it's already a standard. It will be the limit. If you go beyond that, then your answer will be wrong. Okay, since 9.78, so pasok sa banga, less than 9.81 Newton kilograms. This is correct. Gravitational force yung ganon. And now, the other question says, calculate the gravitational field strength at 5,000 kilometers above the surface of the Earth. Okay, nakakaloka. How can you compute for this? Anak, dayon, draw, illustrate. Diba? Okay, illustrate na po, mga palangga. Okay. So, use the same formula. Again, so G is equal to ganun chuba-chucho. Okay, and then G M R squared. Oh, use the same formula. Okay, but your R here is no longer the radius of the Earth only, because there are still 5,000 kilometers above the surface of the Earth. So if this is the Earth, okay, and you have the center here, and you have the radius here that is 6.38 times 10 to the 6th meter, which is the radius of the Earth, and you still have another distance here going to 5,000. Okay, for your another object, let's say object unknown, because it's not mentioned also in the problem. Okay, see, calculate the gravitational field strength by the Earth at 5,000 kilometers above the surface of the Earth. Meaning to say, the object above the surface of the Earth, it was not mentioned, but the distance only is mentioned. Okay, so let's say this is an unknown object. Okay, so this is now wild imagination. Okay, because it's not mentioned in the problem kasi, and there's a 5,000 kilometer. Okay, so you will say mga palangga kung hitad that this gonna be 6.38 times 10 to the 6th meter plus 5,000 kilometer. We have mismatch of the unit. Convert kilometer to meter. It's gonna be times 1,000 because it involves zero. No need to use the calculator. Okay, so 5,000 move 3 0. 1, 2, 3. Like that. Okay, it's gonna become 5 million. 5 million meters. 5 million meters is equals to 5,000 kilometers. Correct me if I'm wrong. No problem if it involves zeros. Huh? It's very easy to estimate and to approximate by your brain cells. But if it involves a lot of numbers, then you cannot do that. Use the scientific calculator. Okay? Okay, like that. So 6.38 exponential to the 6 plus 5 million. Right? Yeah, 5 million. Is equal to 1.13. Okay, 1.138 times 10 to the 13 meter. What's this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1.13 times 10 to the 7 lang siya. Ganon. So this is gonna be hectallion. Right? Start as 1,000. 1,000. Okay? After 1,000, million. After million, you have the billion. After billion, you have the trillion. After trillion, you have the quadrillion. After quadrillion, you have the pentallion. After the pentallion, you have the hexallion. After hexallion, we have the heptallion. This is heptallion because this is raised to the power 7. I am correct, heptallion. Right? Really? Yes. Ganda na, diba? Okay. 7 na siya. Okay. 1, oh, okay, tama siya. No, it's not. Quadrillion lang. Sorry, quadrillion. Okay, because trillion is 1, 2, 3, 4, 5, 6, ba? 1,000, 100, 1,000, okay, million, and then there's another one, billion. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so it's gonna be like that. But that's don't use the terms. Just use the number. Okay, it's not really bad to always have the meaning of the exponent. Okay. So just put the answer it's being asked in the multiple choice or in a fill in the blanks question. For example, what is the term of 10 raised to the power 6? Oh, your answer will be million. If the question will be like that. If it doesn't ask, then don't complicate yourself. Okay? I'm just introducing to you so that you can understand also that there's an equivalent name through each exponent. Okay? Like that. So, ganun siya, no? Then use again the same. Okay? G is equals to the gravitational force constant 6.67 times 10 to the negative 11 times the mass of the Earth, which is 5.97 times 10 to the 24. Okay? It's very easy to memorize the mass of the Earth. Your clue only is there are 24 hours, okay, in one day. So that 24 hours is your exponent. Okay? So the number in brain cells. And then you will add only the 5.97. So it's very easy to memorize. Right? And if you are, for example, if you're very old now, 80 years old, and you have a disease, you're in the hospital, and your apo or whatever ask you, Lolo, what is the value of the mass of the Earth? And you can still answer, 5.97 times 10 to the 24. Oh, see? Because it's already penetrated in your brain cells, even though how old you are. Ganon. So, it's gonna be like that. So, over the radius of the Earth, which is 6.38 times 10. So, you are now relevant as a grandfather, as a father, because you teach your children and daughters about science and math. Okay, di ba? So, you act also as a mentor to your daughters and sons. Meaning, there's additional inputs aside from your teachers and instructors. That should supposed to be like that. Diba? Okay, 6.38 times 10 to the okay, 1.138 times 10 to the 7 mga palangga kung hektar. Ganon. Raise to the power 2 pala siya ha. Ganon. So, 1.138 exponential to the 7. Okay, gawin mga palangga kung hitad. Okay, then raise to the power 2 pa siya mga palangga ha. Okay, so 1.2950 ang imong denominator. 12950 times 10 to the very huge exponent way. Nakakalula. Okay, then 6.67 exponential to the negative 11 times 5.97 exponential 24 is equals to divided by kana siya 3.981199 exponential to the 14 divide mo na siya na value. Okay, pila yung itabo ay hinihigayon na times 6.67 exponential to the negative 11. Okay, divided by 1.2950 exponential to the 14. Now you have 3.07. Our gravitational strength in letter B is 3.07 Newton per kilogram. Okay, so this is now lesser, very lesser. Because the more you have a higher radius, the more your gravitational field strength will become lesser. Okay, it's in the theory here, in a relationship. See, the gravitational field strength is inversely proportional to your radius. Now, if your radius is very big, your gravitational field strength will become less. That's why 3.07. Your radius is being squared now. Whereas on the first version, in letter A, your G is 9.81. Because your radius is less, which is only 6.38 times 10 to the 6, a matter of how much? 10 to the 7. So that's why your gravitational field strength also is 9.81. Okay? Things like that. And then you are sure that your answer is correct. If your answer is the reverse, then you are wrong. Because you did not follow the theory and the principles in that particular equation. That's the relationship, okay, of your quantities per quantities here. So these quantities each have a very, very important role. And you need to understand what is inversely proportional, directly proportional, dependent with each other, independent with each other. Because after you get the answer, you can say if it is you are right or wrong, if it is increasing, if it is decreasing, like that, blah, 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 so and so. Okay, if it will be doubled or tripled, or it will be reduced to a certain degree, something like that. So you will understand. You will review in this manner, huh? Like that. Okay. That's why in the question also in the, for example, in the future examination, always like that. There's also a multiple question that will say, what will happen to your velocity? Velocity is less than the velocity of object B. The velocity will be doubled as the blah 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 so and so. The velocity will be one half as the other velocity will get high. Sometimes you will be confused, too much relationship and too much statements. Okay? So sometimes you're maglibog ka ba? You will be confused. So convert that into mathematical figure so that you can understand what's going on. Okay? Especially if you will get confused with the terminology in English. You cannot understand what is, what is tantamount, like that. You cannot understand what is a parallel to each other. The words being used are not common. Okay? So go to the numbers so that you can interpret that will there. Okay, not the statements. Okay, or reverse, also go to the statements and go back also to the numbers. Okay, ano lang siya. Okay, any questions so far mga panalakong hitan? Okay, so let's summarize into a quick recap. So the gravitational function formula is equal to G is equal to velocity squared raised to the power over the radius. The R here is the radius. Okay. Okay. Now the other one is G is equals to the capital G, which is the gravitational force constant times the mass of the Earth over the R squared. Take note, this G is Earth. If the problem did not mention, okay, that it's not the Earth. If it is not Earth, then follow. If that is not an Earth, don't use the standards of the mass of the Earth and the radius of the Earth. You need to compute, or there's an experimental data to be substituted here. Or last option, you need to derive again another equation to come up with an M and the R. So you can get the simplified derivation equation like that. Okay? Ganon. Ano siya? Equation 1, equation 2. Okay? So, like this. Now, for example, if your sons and daughters really wants to become an astronaut, then they will be having this knowledge very, very adequate to them because this will be applied in the universe. Okay, how the satellite will be, reaching to the other planets, like that, blah, 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 so and so. And how it will float there, we have a high gravity, something like that. So this concept will be applied in the universe. Okay, like that. Ganon. Okay. So, ganon siya. Any questions so far mga palanggang hitad? We will be having our last example before exiting and to going to another topic. Okay? Like that. We have still last problem, but I need to, relax a bit, mga 5 minutes, and I'll be able to come back. I still have 30 minutes to do this quickly. Okay? Thank you so much. If you like this video, you can comment and you can share to anybody else if they are studying physics at this moment in time, or you only know a little bit of knowledge about this topic, then you will be able to have this guidance also. And then if you have sons and daughters that have physics subjects, then you can help also. Or you can message me in my FB Messenger about pure science, basically physics and chemistry. Okay? Like that. Because these are the basic, right? The other sciences are a little bit of difficult. Okay? So, like for example, biochemistry, the combination is a little bit difficult compared to the pure sciences, which is single. The physics, chemistry, and if it is combined, physical, chemistry. So that is more complicated na siya. And then we have a biology, chemistry. Biology plus chemistry is biochemistry. So it will become difficult now. Okay? So, Not so much with environmental science, because environmental science is more on monitoring of the, the atmosphere, lithosphere. Atmosphere, lithosphere, stratosphere, hemisphere, and hydrosphere, excluding the exosphere, because we will never reach in the exosphere, which is the hottest region in the planet Earth. Okay, going to the outer space. Okay, ganon. Okay, litho nga kay land na siya, litho, L-I-T-H-O, meaning the land. That's why lithosphere. And atmosphere, because an air in a Greek word that is atmo. That's why atmo plus sphere is atmosphere. Why sphere? Because it relates that to the shape of a sphere. Okay? Sphere. The volume of a sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. Now, you add the sphere and the prefix. So, to the atmosphere. Oh, that is air plus the sphere. Okay? Lithosphere, the land plus the sphere. The sphere meaning the shape of a sphere. Because we denote as a reference as a sphere. Our previous physicists and scientists in 17th century, 18th century, 19th century, they consider a sphere as a standard shape in determining region to region in the planet Earth. That's why they say atmosphere, hemisphere, stratosphere, exosphere, lithosphere, hydrosphere. Hydrosphere also is water because hydro is water. Okay? And plus the sphere, S-P-H-E-R-E. Okay, so at least you know the volume of a sphere and the area of a sphere. This is very common in algebra, differential calculus, and integral calculus, as well also in differential equations. Okay? The sphere is always be there, the cube, the rectangle and the square, and the cylindrical round opening of a pipe is always being mentioned all the time. Katong ana siya left, pi d squared over 4 is the cross-section of the round pipeline. And you can also have the pi r squared, like that. And we have also the cross-sectional, okay, the pi dl. You need to be alert, when can you use the pi dl? Meaning 3.1416 times the diameter times the length of the pipe. So if this is your pipe, and having a length like this, so compute that in your circumferential area. Meaning to say, your circumferential area is not the same with your cross-sectional area. Because your cross-sectional area is on the opening only. Doesn't consider the length of your pipe. Because if you said circumferential area, you will say pi times d times the length. Okay. Now, but only in the cross-sectional area, pi d squared over 4 or pi r squared. And you need to be, alert. Because this will be also mentioned in the designing of different equipment, for example, heat exchangers, evaporators, or any unit operations, for example, a fractionating tower, a benzene tower, something like that, or a chemical reactor, if you want to work also in a nuclear power plant. Okay, the chemical engineers also will be there, or the time the processes, something like that. And you need to understand this is more on the design operating parameters in every equipment, because during the designing stage, you need to know this. And that's the time you will integrate, differentiate, integrate, differentiate, integrate, differentiate, so that you can have a good design of your equipment, whether it is a stationary equipment or a rotating equipment. Okay? Something like that. So it's going to be a mixture now of a mechanical engineering part and also a chemical engineering part. Okay? So basically related a bit. Because if there's no media, then if there's no water, then useless. The equipment will be useless. Okay, if there's no solid, liquid, and gas that will go to your equipment, so it's useless. Okay, that's why the chemical engineer will come in, because there are always substances that this equipment will be driven. Okay, example, lathe machine. So you will make a shape of a metal. Metal is under chemical engineering or chemistry. So it's impossible that the lathe machine don't have the metal in doing that job. So it's useless that way. Mechanical engineering, chemical engineering are closely related to each other. Okay? You get the point, mahanap siya. You get the point. That's why we have the same subjects, them also, with the fluid mechanics, like that, thermodynamics, what else? Quantum mechanics, statistical mechanics, something like that. So we almost have a similar subject. Not all, but similar. We use also processes also in different equipment. We also do that, okay, in the design, especially in the plant design. Okay, something like that. Plant design or equipment design. Okay, you will never become an engineer if you will never be graduating, if you will never pass the equipment design and a plant design. Okay, just like a thesis or a feasibility study. Okay, ganon. Makakaloka. Diba? Oh, my grade in plant design is 4.7. And our CIT University is having a 5 highest grade, the same as, I think it's gonna be LaSalle or Ateneo in the whole Philippines. With only 2 schools have a highest grade of 5. CIT University, and I think it's gonna be LaSalle University. But I doubt I'm sure there are only 2 schools or universities or institutions in the Philippines that the highest grade is 5, is not 1. If you ask the technologians with the CIT University, why 5? Because numerically, 5 is higher than 1. 1 can never be higher than 5. So that's our reason why our highest score is 5 in the grade, not 1. Then if you try to put that in a ranking, that's why 1 is on the top. But we are not talking of the ranking, we are talking only of the score as a numerical figure. Okay, that's why 5 is higher than 1. Kailan ba maging mataas ang 1 sa 5? Explain. Statistically, 5 is higher than 1. That's why our score is 5 is the highest, not the 1. Because we are not asking for ranking. We are not computing for the honor students, cum laude, magna cum laude, that we need to get the rank or the top. We are only saying the score of any individual student. So we go to the English grammar, we go to the statistical figure as a numerical figure. That 5 is higher than 1. Okay, that's why our grade in our school is 5 equal to 100%. So ako kapala plant design is ano pa na? 97%. Uy, disclaimer ha, sa inyo ko yung habugiroon. Okay? I'm just telling the truth because I want you to be inspired and to be motivated. Okay? Because plant design is not very easy. So I got a very high score because I can defend very well. Okay? Because this is, you need to be asked by a panel of, 3 persons. You need to justify your feasibility study in front of them. Since, again, wala ko ng hambog, I am very articulate in my English language and communication in front to the interviewees. That's why I got 4.7 in my plant design grade. Okay, in Cebu Institute of Technology University. So any questions so far for this? Okay, just message me in my FB Messenger, right? Okay, so let's end. Bye-bye. God bless everybody. Remember, my friend, that Jesus loves us. Thank you so much. God bless. I'll be coming back for another problem. I still have time. Oh my gosh, because I'm very, very talkative. Oh my gosh, I still have. Thank you so much. Okay. Shout out sa akong niece. He will be going to United States of America to teach. Okay. He messaged me like that. Okay. So